Find the axis of symmetry and the vertex of y equals x squared plus 6x plus 5. Well, you might recognize this from a previous video that we looked at, and in that video we were asked to find the x-intercepts. And we found the x-intercepts by first factoring this side of this quadratic equation. We found specifically that this statement is the same as x plus 5 or multiplied by x plus 1. And if you want to confirm that, that's quite easy to confirm. You just have to expand this and you'll find that this orange statement, if expanded, equals this yellow statement above it. And from that, we discovered that if we input x equals minus 5, then y equals 0. And also if we input x equals minus 1, then y equals 0. So consequently, the x-intercepts we found were minus 5, 0, and also minus 1 and 0. Well, given that information, we need to first find the x-intercepts if we ever want to find the axis of symmetry in the vertex of a quadratic function. Given these x-intercepts, let's go ahead and first find the axis of symmetry. So the axis of symmetry, you might recall, is the line about which a parabola is symmetrical. So I've constructed this graph here. This is a graph. This blue graph shows the graph of this particular quadratic function. And we can see quite clearly that the line about which this has symmetry is this line just here. And so the question is, what is this line? What is the line that gives, what is the equation of the line that is the axis of symmetry here? Well, an important thing to know about the axis of symmetry is that the axis of symmetry is always a vertical line. So that means that the axis of symmetry, it always takes the form of x equals some number, some value. So the axis of symmetry is going to be x equals something. And that value is going to always be the average of the two x coordinates of the x-intercepts. So here in this graph, the x-coordinates, or the x-intercepts, we've got one x-intercept here, and we've got another x-intercept here. In fact, we can label these. We can see that this x-intercept this happens at minus 5 on the x-axis, and this part of the graph intersects the x-axis here at x equals minus 1. So we can clearly see that this line here, this axis of symmetry, that goes through some x value here, and that x value is the average of these two. Or another way of saying it is that the point at which this line crosses the x-axis, that point just here, that point is the midpoint of these two x-intercepts. So the easy way to find the axis of symmetry is just to write x equals the average of minus 5 and minus 1. And the reason it's the average of minus 5 and minus 1 is that minus 5 and minus 1 are the two x-coordinates of the two x-intercepts. So in order to find an average of two numbers, we add those two numbers together and then we divide by 2. So this is the same as saying minus 5 plus minus 1 all over 2. Well, negative 5 plus negative 1, that is the same as writing negative 6 over 2. Well, 6 divided by 2 is 3, so negative 6 divided by 2 is negative 3. So the axis of symmetry is the line given by x equals minus 3. That's the answer. So this line here, this is the line x equals minus 3. Well, we found the axis of symmetry. The next thing we need to do is find the vertex. So let's consider the vertex. And you might recall that the vertex is the point at which this graph crosses the line of symmetry. Now the axis of symmetry is given by the line x equals minus 3, so we know that any intersection with this line, that point must have an x-coordinate of x equals minus 3. Turns out the vertex we can see is this point right here. So this vertex, this vertex will have a point where the x-coordinate is minus 3. And then the only thing we'll have to figure out is this y-coordinate. So here we know that the vertex will be minus 3 and something. In order to figure out what the y-coordinate of the vertex will be, we need to substitute the x value of -3 into our original equation and determine what y equals when x equals -3. That's how we find the vertex. So here we're going to substitute x equals -3. So at x equals -3, we're going to have y equals, then we'll have -3 squared, plus 6 multiplied by -3 plus 5. So I've just substituted x equals -3 into this equation. Let's simplify. Well, -3 times -3, and negative times a negative is a positive, and 3 times 3 is 9, so this is going to equal 9, plus 6 times -3, that's going to be equal to -18. So we can just write negative, so this is 9 minus 18, and then we're going to have plus 5. Well, let's simplify this further. 9 minus 18, that's going to be -9, plus 5, that's going to be equal to -4. In other words, we can write the vertex here as -3, and the y-coordinate, here the y-coordinate, is going to be -4. So we can fill out this point down here as -3, -4, that's the vertex. Thus the vertex here is -3, -4. And that's how to find the axis of symmetry and the vertex of a quadratic function.